All right, guys, we got inverse trig functions today. Inverse trig functions, and should be, if you remember your values, it should be one of the easier days you've had in a while. So let's hope you remember those. All right, a couple things here. I'm going to minimize this one a little bit. Trig functions, as we used to graph them, look like that way back when we graphed those. If you look at the middle, that's cosine graph. If you look at the bottom down here, that's what sine look like. If you look at the top, that's what tangent look like. Well, if you're doing inverses, remember you switch your x and y. So your x and y axis switch, the graph basically does this right here. Your x-axis becomes your y-axis, your y-axis becomes your x-axis. And when you do that with sine and cosine, what happens is they're not functions anymore because they failed the vertical line test. So what we have to do is something called restricting the domain. We restrict it to just part of the domain. If you look at the sine graph right here, just the red part, that does pass the vertical line test. So we're going to use only that part for our inverse sine graph. All right, so that means we're going to go from -1 to +1 on the x-axis, which used to be our y-axis, and from -π/2 to +π/2 for the y-axis, which means that's our range. Our range is between -π/2 and +π/2. So if you're thinking unit circle-wise, that's quadrant 4 and quadrant 1. Inverse cosine, restricted it also. It still goes between -1 and +1 on your x-axis, which is your domain. Your range is going to be from 0 to pi. Remember, your range is how far up and down your graph goes. So 0 to pi on your unit circle would be quadrant 1 and quadrant 2. That's important. And tangent, there's no restriction because even when we turn the graph sideways, it still passes the vertical line test, so it's good. So your domain is all real numbers, and your range is from -π/2 to +π/2, which is the same as sine was, which is quadrant 4. All right, the other picture here is just says that in words. When you're doing inverse sine, two ways to write inverse sine. One is with the -1 exponent, which is the way I use it most of the time. The other thing is you can write arc sine, which means inverse sine. Your domain is this. Your range, that's important, -π/2 to +π/2, or quadrant 4 or quadrant 1. Inverse cosine or arc cosine, your domain is the same, but your range is a little different. For cosine, we're going to use quadrant 1 or quadrant 2. Inverse tangent or arctangent, domain is all real numbers, range is the same as sine. So cosine is kind of the weird one, in that we're using quadrant 1 and quadrant 2 to get our positive and negatives, and for sine and tangent, using quadrant 1 and quadrant 4. Let's look at a couple here. This first one says inverse sine of square root of 2 over 2. All that's asking you guys is, where is sine square root of 2 over 2? Well, that happens at pi/4 in quadrant 1, which is in the domain. That's all you got to do. On part B, where is cosine -1/2? Well, cosine is -1/2. It's a half at pi/3, but because it's -1/2, it's going to be 2 pi/3. Don't forget, with cosine, you have to use quadrant 1 for your positives, quadrant 2 for your negatives. Sine, we're using quadrant 1 for our positives and quadrant 4 for our negatives. Here's an example right here. Tangent, -√3/3. That's a pi/6, but it's negative. And with tangent, just like sine, we use quadrant 4 for our negatives. So let's go put a negative sign, -pi/6. All there is to those. All right, if there's one you don't know, we're going to punch in the calculator. This one says find both radians and degrees, 4 decimal places, and there's 1/10 of a degree. So I'm going to do radians first. You're going to punch these in your calculator along with me to make sure you're getting it. Check your mode to make sure you're in radians. Doing radians first, I'm going to do second cosine. If you look above your cosine button, you'll see the cosine -1 or inverse cosine button. And I'm punching in -0.2689. And I'm getting this answer right here, 1.8430. That's the radians. Now if I change the mode to degrees and do the same thing, I'm going to go second cosine, -0.2689. And I actually hit the wrong button. Second cosine, -0.2689. And I got 105.6 degrees. And let's do one more of those. Second tangent, so I'm already in degree mode, so I'm going to do degrees first. Second tangent of negative, same number, 0.2623. It's not the same number. I got -14.7 degrees, 1 decimal place. And then change it to radians. You go to mode, change to radians. Go second tangent, same number, -0.2623. And I get -0.2565. You're going to punch those in, make sure you got the same thing I did, but those are just flat out punch in your calculator, but make sure you're in the right mode. All right, composition of functions, last thing we're doing today. Composition, this really works kind of crazy. If you're taking the sine of inverse sine of x, you just get x. That should be common sense to you by now after all the inverse stuff that we've done, as long as x is in the domain. Same thing is true for cosine, same thing is true for tangent. As long as they're in the domain of inverse cosine, inverse tangent, you can just put whatever number you have. It's called composition, combining two functions together. When we proved things were inverses a couple weeks ago, we would do like f of g of x is x and g of f of x is x. That's what this is. This is composition with trig. Also works the other way. Special cases, inverse sine of x, inverse cosine of x, inverse tangent of x, they all equal x as long as x is in the range of inverse sine, inverse cosine, inverse tangent. Those are a lot of words. Problems are actually not very hard at all. It kind of looks like they cancel. They don't, but they kind of do, but they don't. And I'll show you how it works right here on the next slide. Okay, this first one says cosine of inverse cosine of negative square root of 3 over 2. All right, so if I work inside out, if I work that inside parentheses, it's asking me where is cosine square root of 3 over 2? Well, that's at pi over 6. So now I have, what is cosine pi over 6? Well, that's square root of 3 over 2. So that's what those properties were just telling you. Cosine of inverse cosine is always going to be the x or that number as long as it's inside the domain. And this time it was, or in the range of what's possible. Now the second one says sine of inverse sine of 1.8. Now, one issue here. There is nowhere where sine is 1.8 because there's nowhere where sine is bigger than 1 or less than negative 1. So that does not exist. It can't happen. So that's what it meant when it's talked about the domain on the last slide and the range. It must fit inside your domain and range for it to work. All right, a couple more here. This is inverse tangent of tangent pi over 6. So again, if I work this inside out, tangent pi over 6 is square root of 3 over 3. Now the problem's asking me, okay, where's tangent square root of 3 over 3? Well, at pi over 6. So as long as these are the inverses of each other, you're good with that answer as long as it's within your domain and within your range. So should be good to go there. Same thing on the second one. This is saying inverse sine of sine 3 pi over 4. Well, sine of 3 pi over 4 is negative square root of 2 over 2. And here's where it gets a little bit different. Inverse sine of negative square root of 2 over 2. Remember, for inverse sine, you can only use your range is quadrant 4 and quadrant 1. And since it's negative, you've got to use the quadrant 4. So you have to put negative pi over 4 there. Don't get caught up in just saying, hey, this is going to be the same number. I think I'll just put 3 pi over 4. It must fit within the domain and range. So probably working it out that way is probably a little better. Okay, last thing here. What if they switch them up on you? If they do, no big deal. Work your way inside out. It says sine of tangent, inverse tangent negative 1. What is inverse tangent of negative 1? And where's tangent negative 1? At negative pi over 4. And what is sine at negative pi over 4? Negative square root of 2 over 2. So it's kind of like two problems in one. But you're just working the inside out. So the second one more here and we're done. This one says inverse cosine of sine pi over 2. Well, sine pi over 2 is 1. So now it's asking you, where is cosine 1? Well, cosine is 1 at 0. And you can't put 2 pi because your domain for cosine has to be between, or inverse cosine has to be between quadrant 1 and quadrant 2, or between 0 and pi. Hope that makes a little bit of sense. This really isn't bad at all. If you know your values, I hope you remember your values. And if not, probably I'll learn them again. And I will see you tomorrow and we'll work on these things. Again, not too bad. See you tomorrow.